Okay, guys, today we are going to start Unit 9, which is all about data and statistics. Okay, so our Unit 9 starts with Lesson 1, which is measures of center and variation. You can see our learning targets at the top: compare mean, median, mode of data sets, describe the effects of outliers, and find the range and standard deviation of sets. Okay, so we're going to start off with the vocab here. A measure of center is a measure that represents the blank, okay, which is the center or typical value of a data set. So put that in here. The mean, median, and mode are all measures of center. So they represent that middle number or somewhat in the middle of the value sets that are normal. Okay. The mean of a numerical set is the sum, which means you're going to add all the numbers together, of the data, right? So the sum of all the numbers divided by, okay, the number of data values. So you add them all up and divide by how many there are. The symbol X with a bar over top represents the mean. It's read as X bar, which should make sense. Okay. The median, so we've got mean here. Let's do median. Okay. The median of a numerical set is the middle number. And I always like to remember this as when you're driving down the highway, there's a median in the middle of the two roadways. So median's in the middle. And you get this value when the numbers are written in numerical order. So in order from least to greatest. Okay. When a data set has an even number of values, the median is the mean or the average of those two numbers in the middle. So you would add them together and divide by 2. Okay. So last one here would be the mode. Okay. The mode of a set of data is the value or values that occur most often. So I always think about mode means most. All right. So the thing you need to remember about mode is there may be just one mode. There might be not one at all if nothing appears more than any other number. Or there could be more than one. So if you have 2 or 3 numbers that all appear the same amount of times, then there's going to be more than one mode. Okay? So let's take this into finding the actual values. All right? So, first thing, an amusement park hires students for the summer. The students' hourly wages are shown in the table. Find the mean, median, and mode of the hourly wages. So what we're going to do first is add up all of the values in this table. So I'm going to add this side, I'm going to add this side. And when I add those together, the total of all of them, the total sum, I'm just going to put it here, is $77.20. Okay? So for the mean, I'm going to take 77.20, which was the sum of all of them, and divide by how many there are. And there are 8 different values. So divided by 8, and that equals a mean of $9.65. Okay? Then we've got the the median, right? And the median is when we put all of them in order from least to greatest and find the middle number. Okay? So in order, we would have 825, 825 again. And I always like to cross them off or give a little check mark when you use them so you know which ones you've gotten. 845, 865, right? So there's those two. 875. Then we have 910, 925. And our last one up there is 1650. Okay, so if we look, the middle, there's 1, 2, 3, 4, 5, 6, 7, 8 values. That means the middle two are 865 and 875. So we would have to add those together and divide by 2. So 865 plus 875 divided by 2 gives us $8.70. Okay, so there's my median. All right, and then the mode would be the number that appears the most, right? And so our mode is 825 because it's the only one that appears more than one time. Okay, so I'm going to put up here, my mode is 825. Okay, so I've got all three. Now, the next question says, which measure of center best represents the data? So for this one, it would have to be the median because it's falling more towards the middle, which is where most of this data is. If you look, the mean is a little bit high. 965 is clear over here in the ranking of where that would be. And the mode is 825, which is clear down here on the end. So we would have to pick the median because it's closest to all the data points. Okay. Again, sorry, this is kind of lagging. The mean is a little bit high and the mode is kind of low. So we want to pick the one that best represents it. Okay. Okay, so it says, what if the park hires another student at an hourly wage of $8.45? How does this additional value affect the mean, median, and mode? Explain. Okay, well, to do the mean, right, we would have to go back and add in another value. So it was 77.20. We would add in another $8.45. And then we would have to divide that now by 9 values because I added in an extra data value. So this would actually end up equaling $9.52. So that one actually went down a little bit for our mean. Okay. The mode, well, if I add an 845, that means it gives me 2 of these for the 845 here, and there'll be another one. So then our mode actually becomes 2 values that appear the most, which is 825 and 845 now. So that changes a little bit. And then our median, right? So if I put in our median, that means that you would fall in 845 would be here as another one that you could put in to the middle, which means that it would shift all of our values 1. So this would be 1, 2, 3, 4, 5. And you'd have 1, 2, 3, 4, and then this would be your middle. So the median would be between those two. So it would be 875. Or 865, I'm sorry. So that would be 865 to be able to put that one in there. Okay, so which measure of center best represents the data now? And explain. Well, again, it would be the median, right? Because same thing, the mode's a little too high. It would be clear up here at 952. And then, I'm sorry, the mean, and then the mode is down here on the lower end. So 865 is still in the middle, and you always want to pick the one that measure of center means it's closest to the middle, right? So the median is still going to be our closest. Okay? All right, so on to the next screen. We're going to talk about outliers, okay? And an outlier, which you should remember from your junior high days or your middle school days, an outlier is a data value that is much higher or much lower. So much higher or much lower than the other values in the data set. Okay, so in the data we just talked about with the hourly wages, The outlier here would be 1650 because it's a lot higher than everything else that's in there, right? So 1650 would be our outlier. How does the outlier affect the mean, median, and the mode? Okay, well, if I take out the outlier, we had 7720 earlier, right? Minus 1650. And then if you take it out, there would only be 7 data values. Okay, so that would mean that our new mean would be $8.67, which is a lot lower and closer to the middle than the other one was. Okay, so that one went down. Then if we look at our median, okay, the median, if we took that one out, would be 865. So that one also went down from the original. And then if we looked at the mode, if we take that one out, the mode isn't affected. It's still going to be 825 because remember, this is just the number that occurs the most. So it's still the same. So what would be, I mean, if you take out a high value, that should make sense that everything drops a little bit. And again, mode's not really an example of that because it's not going to affect how many times something is happening. But if you take out a higher number, it's going to automatically drop everything. If you take out a lower number, things would get higher. So, describe one possible explanation for the outlier. Well, if we're thinking about hourly wages, maybe 1650 is like a manager. So, could be a manager at the place where we're talking about. Or maybe it's somebody that does some type of special job, like a technical job, and they just make more money during that time. Okay. Outliers, things that are much higher or much lower than the rest of the data. Okay. A measure of variation is a measure that describes the spread, okay, or the distribution of the data set. So measure of variation is what we're looking at here. One of those is range. So the range of a data set is the difference of the greatest value and the smallest value. So difference means we're going to subtract. So I just always say we subtract largest minus smallest. Okay? All right, so finding the range. 2 reality cooking shows select 12 contestants each. The ages of the contestants are shown in the tables. Find the range of the ages for each show. Okay? The one thing you have to be careful of here is that they're not always in order. So if you're looking just at the very first and the last number, you have to be very careful because they're not always going to be the biggest and the smallest, right? So if we look over here, show A has a low value of, it appears to be 19, right? And then a high value actually is the last one here, which is 31. Okay, so for show A, we are going to have 31 minus 19, which gives us 12 years as the age range for this cooking show, right? And then if I switch over to show B, okay, show B, the smallest age range there looks to be 19 as well, but the largest age or biggest age is 48. So for show B, it's going to be 48 minus 19, which equals a range of 29 years in age difference for this one. Okay? So largest minus smallest for the range. That should be familiar. You've done that before. So a disadvantage to using the range to describe the spread of the data set is that it only uses 2 of the data values, right? So you're only using the biggest and the smallest, so you don't really know a whole lot about the data set, just that the biggest and the smallest are differing in that amount. A measure of variation that uses all of the data values in a set is called the standard deviation, and that's what we're going to look at next. So standard deviation. The standard deviation of a numerical data set is the measure of how much a typical value, okay, so not an outlier, a typical value in the data set differs from the mean. So mean is your average, right? And we're looking at how much does one of those values differ from that. The symbol for this represents standard deviation. So it's read as sigma, okay? And it's given by the formula that's listed here. So this formula, super important, okay? Here's your standard deviation symbol, okay? Now, I don't think there's any need for you to remember what this formula is, but the steps are going to be important for you to remember as we go through, okay? So n is the number of values in the data set. The deviation, this should say of, the deviation of a data value x is the difference of the data value and the mean of the data set, okay? So I'm going to kind of just jump down here. These steps I'm going to explain a little bit more down below because it tends to get a little hard to understand with all those steps in this process, okay? So last part here, we're almost done. But when we're talking about standard deviation, a small standard deviation means that the data are clustered around the mean. So they're really close in value, okay? A large standard deviation means the data are more spread out. So it depends on what you're talking about, but the data are going to be more closely related to each other if they're clustered. If they're more spread out, you're more likely to have differences in your data values. Okay? So, step 1 is going to be to find the mean of all your values. Okay, so I'm just going to come over here and put step 1, average of values. Okay, so that means I'm going to add up all of these values over here that they already gave me. These are all going to be added together, right? So when I add them all up, this actually equals 300. Okay, and then I have to divide by how many there are, and there's 12 of them. So 300 divided by 12 equals 25. Okay, so that's step 1. Okay, step 2, we are actually going to subtract the values from the answer in step 1. Okay, so I'm going to put our answer here down in this column, just repeated 25, 25, 25, because this was our, sorry, kind of had a pause there, just stopped writing. So I'm going to do 25 all the way down. Okay, so then step 2 is to actually subtract those, so it goes right here. Okay, so step 2, we're going to subtract our values from answer in step 1. Okay, so those answers there are going to leave you with 20 minus 25, so that's negative 5. 29 minus 25 is 4, and so forth. So I'm going to have negative 6 here, negative 3, 0, 2, 2, 4, 5, -5, -4, and 6. Okay? So that was step 2, subtract. Now, step 3 is going to be squaring those numbers to go here. So this would square them all. So kind of take these and go this way with it, right? So step 3, square those answers. Okay? So -5 squared is 25. 4 squared is 16. -6 squared is 36. And we're going to go so forth. So this would be 9, 0, 4, 4, 16, 25, 25, 16, and 36. Okay? Now, the next step is going to bring us back around to the first one, which is we're going to find the new average of those answers. Okay? So step 4, find the average again. Okay, so when I add all these up, okay, the total now is 212. And I have to divide that by 12 again. And that answer is 17.7. Okay, so step 5 then is we are going to square root the mean or the average that you just found. Okay, so my last step is I'm going to take the square root of 17.7, and that equals 4.2. Okay, this means that the typical age for a contestant on a show differs by 4.2 years from the mean. Okay, so our first mean was 25. This one is 17.7. So it differs by about 4.2 years. Okay, so standard deviation process. Find the mean, use that to subtract from the first set of values, square it, find the mean again, and then take the square root of that number. Okay? Good job.